Hey guys, so now that you understand a little bit about velocity and how to find the velocity equation given the displacement equation by differentiation, we're going to go on to finding the acceleration. So if you're looking at the screen right now and you have no idea what's going on, you probably need to go back to our previous lesson where we talked about displacement and velocity before you deal with acceleration. So let's firstly define what acceleration is. Now, acceleration is the change in velocity over the change in time. So in other words, we have an object that is moving faster and faster or slower and slower. So the speed is changing or the velocity is changing. So if you driving a car, for example, and you step on the accelerator, chances are your car is moving faster and faster, so that is an acceleration. Another case of when there is no acceleration is, for example, if you were driving your car and your speed is constantly staying at 60 kilometers per hour, for example, then the acceleration is zero. Right? Otherwise, if the acceleration is changing from, let's say, when the object is stopped, when your car is at a stop, to when it is moving at 60 kilometers per hour, during that time there is an acceleration. So let's go back to our graph that we just drew in our last lesson, where the curve represents the displacement versus time of the object, and the tangent line is the speed, is the velocity of the object. And you can see that the velocity is always changing, right? There is pretty much no 2 points where the velocity is the same. All right, the gradient of the line is always changing. So let's get our equations back up. We have the displacement equation, S is equal to -5 bracket t minus 2 squared plus 20. That is the displacement. And we have the velocity, which is the rate of change of displacement with respect to time, ds dt, ds over dt, is equal to, so we differentiated that into negative 10t plus 20. And if you have forgotten how we differentiated it, basically we expanded the displacement equation, which gave us negative 5 t squared plus 20t, and we just applied the differentiation formula which gave us that. And now, because acceleration is the change in velocity over change in time, we have the acceleration is equal to dv over dt. Alright, the derivative of velocity is acceleration. And if you differentiate this, you get negative 10. And that's it. Negative 10 is the acceleration throughout the whole graph. Now, does that make sense? Well, let's have a look at the graph and see what's happening. So originally from here, when at the start of the graph, the velocity is 10. the velocity is 20 because we can see the gradient of the tangent line is 20. And now let's look at when time is equal to 1, the gradient of my tangent line is now about 10. And let's go to the gradient at time is equal to 2. There is no gradient, or because the rise is 0, the gradient is 0. So the gradient is 0, so it went from 20 at this point to 10 at this point to 0 at this point to negative 10 at this point to negative 20 at this point. So throughout the whole time, as time increases by 1 second, the velocity decrease by 10 meters per second. So that is why the acceleration, which is the change in velocity at any point on the graph, is negative 10 meters per second squared. Or we can say negative 10 ms to the power of negative 2. So that is the acceleration of the object at any point on this curve. Okay, thanks for watching the video on acceleration. See you guys next time.